Alright, stop.
To prove that the Hover Squad was and is capable, they created the STYROCRAFT, a hovercraft made only of styrofoam, and some parts from a drone, I guess.
Okay.
That I have to go away from our FEDD project, aside from the fact that it was a traditional class project, is that it provides our youth with real-world and valuable experience in issues of problem-solving, work management constraints, and all those types of industry-related problems that we wouldn't have been able to experience had it just been something we were doing within the class, not something else.
What is a hovercraft?
The hovercraft was designed to create a cushion of air under the craft through fans blowing downward to lift the craft. As that's being done, a fan at the back is blowing air backwards to push the craft forward. Newton's third law explains that any action has an equal and opposite reaction. So that's the main premise behind the hovercraft design.
The hovercraft was invented in 1955 by Sir Christopher Cochrane. It was quickly classified and sent to the military because the idea was that a vehicle that could move over air, land, or sea could be very useful for military applications. However, no branch of the military wanted it because it was either impractical or outside of the scope of that branch of the military. Eventually, a company called Saunders-Roe picked up the project, creating the Saunders-Roe Nautical 1. This was the first commercial hovercraft ever created. It famously hovered across the English Channel in 1959, and the rest is history.
Alright, so here we have our finalized version of our hovercraft. So throughout our design process we went through a lot of different versions, but this is what we eventually came up with, and we have our two central lift motors right here with our two thrust motors in the back, and if you notice the cagings around the motors that we had to make for safety purposes are actually used from cups within Fountain Dining Hall, so that was pretty cool. And then this styrofoam plate was just something we found on Amazon. And we have these two lights up in front, which you can see in the video here. And not only do they look cool because we have those combined with the LEDs on our motors, but they also acted as a counterweight on the front of our hovercraft, so that helped us a bit as well. But yeah, this is our final design.
The engineering design process is something that's vital in the lives of every engineer. It's important because you need to start at the beginning and figure out what the problem is and how you're going to use the constraints and the time that you have to solve it. So when you start, you have to figure out what, like for our FEDD project, we had a budget, we had time constraints, we had scheduling issues, we had to figure out how we were going to make the project work. Then we had to figure out which ideas would work best for what we needed it to do. Once we moved from the ask section, we started to imagine what our hovercraft could be. We did research on the different types of hovercraft to figure out which would be best for our purposes. Once we chose the best one, we moved to the plan section, where we started diagramming and figuring out which materials we would need to make the hovercraft the best it could be. Finally, we started to create it, testing it out, modifying it to see how we could get it to be as fast as we wanted and to look as great as it did. Next, we started to improve because we have to always continually be improving to make it as best as the hovercraft could ever be.
So this is our first version of our hovercraft, and as you can see, there were a lot of things initially that we needed to change to get to our current design. So one of the first things immediately apparent that you can see within our first iteration is that we do have a very rough idea of a skirt, which we eventually got rid of because we realized it really wasn't doing us any help. It was just slowing us down, and we had decided to go with an open plenum from the beginning, so we didn't really need a skirt regardless. We just needed some material across the outer edges, which we eventually ended up going with electrical tape to reduce the amount of friction and provide the smoothest contact possible between the hovercraft and the surface we were going over. Another thing that we changed was the way that we affixed our thrust motors within the central portion of our hovercraft. So we originally had them mounted to a piece of chopstick running laterally across, or longitudinally across the hovercraft, but we changed that we had them running laterally, and then we changed them longitudinally so that we had them mounted with the chopsticks in this direction. As you can see from the top view, they'd be coming out like this. And as you can see on our craft, this is how we changed them so they're mounted like this. So that takes away from some of our airflow being removed by this central beam, and it just sort of smooths everything out.
In addition, originally we had our circuit board here mounted upside down. The model of drone that we worked with had an accelerometer built into the circuit board, so it being upside down made it so that the motors weren't running correctly. 3 of them would turn, but 1 of them just wouldn't because it was trying to correct for being upside down. In our final project here, you can see that we also included cages as a safety measure. This way, if somehow the hovercraft went off the track and somebody picked it up, it wouldn't cut anybody's finger off, for instance. It also helped direct the airflow downwards. You'll also see on this version, though not in the pictures, we have lights affixed to the front. This was added as a counterweight to keep us from doing this little number and getting off track during the hover track.
Another thing that we also added within this version to solve that issue with the accelerometer within the circuit board is we made sure that there was a piece of popsicle stick running over the top of the circuit board so that it was as close to being perfectly flat, if not perfectly flat. So that helps reduce that. And then you can also see with the inclusion of these cups that we have a much more sealed enclosure around these to try to capture as much, suck as much air down in there as we can.
And it looks much nicer.
It does.
Message